Welcome back. Today I am going to discuss about heap sort mechanism. This sorting algorithm related to binary heap. A binary heap is a binary tree which has two special properties. Number one, shape property, and number two, order property. In shape property, a binary heap must be a complete binary tree. And in case of order property, if you want to do max heap, it has also two categories, max heap and min heap. In case of max heap, the item of root or parent must be greater than or equals to its children, and in case of min heap, the element of root must be smaller than or equals to its children. If you want to sort some numbers in ascending order, then you have to do max heap, and for descending order you have to do min heap. Look at this image. Here I have taken one array. The size of this array is 7, but elements are 6, because you have to leave the starting element here. It has also one reason we will discuss later. Elements are 20, 30, 15, 25, 35 and 22. And now firstly we will create a binary tree, complete binary tree. And the concept of complete binary tree is, suppose you are inserting first node, that node will become the root node. Next node will become the left child of this node. Without inserting left child, you can't insert as right child of this node. Next node will be right child of this node. Again, fourth node will be left child of this node. All nodes will be inserted from left to right in each level. Then the tree will be considered as a complete binary tree. Okay, so all elements will have inserted here from left to right. Okay, 15 has no any right child, 20 has two child, 30 and 15, 30 has two child, 25 and 35, and it has only one child, 22. And imagination will be, suppose in case of 20, index is 1, and so left child will be 2 into I is index. Now 2 into 1, 2. Left child of 20 will be 2, that is 30. And right child will be 2 into I plus 1, that is 3. 2 into 1, 1, 2, 2 plus 1, 3. Right child will be 15. So the element 20, it has two children, 30 and 15. In case of 30, the index is 2, and 2 into 2, 4. So left child of 30 will be 25, fourth index, and right child will be 2 into 2 plus 1, that is 5, 35. Okay, 30 has two children, 25 and 35. Okay, 25 and 35. Okay, now we will create max heap of this tree, and to create the max heap we take the last subtree. It is the last subtree here. Suppose a complete binary tree. Okay, it is a complete binary tree, and to create max heap you have to follow from here. Create this subtree as max heap, then it will be considered, then this subtree, and at last this. It is the process for creating max heap. Is this subtree a max heap? No, because 15, the parent node contains a child which is greater than parent. So one interchange will be done here between 22 and 15. So it will be 22 and it will be 15. 15 and 22. It will be 22 and it will be 15. Now we will consider this. Is it max heap? No, because this is 30 and this is 35. 35, 25. Which one is greater? 35 is greater. So these two elements will be interchanged. It will be 35 and it will be 30. Same in case of array, it will be changed. Okay. Now the first subtree, is it max heap? No, because parent is 20, it has greater child 35. So one interchange 35 and 20 will be done here. It will be 35 and it will be 20. 35 and 20. 35 and 20. These two elements. It will be 35. It will be 20. But after interchanging, the order property of this subtree will be violated, because if 20 comes here, then your one child, right child, that is 30. 30 is greater than 20. It will violate the properties of complete binarity. Max heap, and so one interchange will be done here more. It will be 30, 30 and it will be 20. Between 20 and 30, 20 and 30, these two elements will be interchanged again. It will be 30 and it will be 20. And now this tree is a max heap. And after making max heap, the element of root will be greatest element of entire tree. Second step will be, at first you have to build a heap, and second step will be interchange between two items, the root and the last item, that is 35 and 15. One element will be eliminated from here. Okay. This is the status of array, and here you have to interchange 35 and 15. After making heap, one element will be interchanged with the last element. So it will be 15, 35 will go to last position, this 35. It will be 15, it will be 35. And for next time, we do not consider this item, this node. Okay. And after interchanging, the order property of binary heap will be violated, because the last item has become the root node here, and so it may violate the properties of binary heap. And so again we heapify this tree using same rule. Heapify means rearrange the items. Okay, and here we rearrange all items from up to bottom. 15, it has two children, 30 and 22. Greater item is 30, so interchange will be done here between 30 and 15. So it will be 30, it will be 15, 30 and 15. It is 15, it will be 30. Okay, follow here. 15 smaller item, greater item is 25, so again interchange will be done. It will be 25, it will be 15. And 25, 15 and 25, these two items. 25 and it will be 15. Okay, now again it has become a binary heap. Okay, and status of this tree is here: 30, 25, 22, 15, 20 and 35. 35 is eliminated item. Okay, again heapify, interchange the root item with the second last, that is 30, 20 and it will be 30. It will be 20 and it will be 30. This is eliminated item here. It will be eliminated, and again heapify these from top to bottom. 20 contains two items, 25 and 22. 25 is greater, so interchange these. 25, 25 and it will be 20. Okay, this is eliminated item, so it will not be considered again. And 20 has one item here, 15, that is lower item. It is correct. Okay, so 20 and 25 we have interchanged. Okay, we have interchanged these two elements, 25 and 20. Okay, the status of this array is 25, 20, 22, 15, 30. It is eliminated item. Okay, these two items will not be considered again, 22 and 35. Interchange the root item with third last. It will be 15, it will be 25. 25 and 15, it will be 15, it will be 25. Again heapify from top to bottom. Now it is also eliminated item, so last level will be eliminated here. Consider this one only. 15, 20 and 22. 22 is greater, so these two elements will be interchanged. 15, it will be 22 and it will be 15. Okay, 22 and 15. it will be 15, it will be 22, this is the status of array. Again interchange with root, fourth last with fourth last, 22 and 15. 15, it will be 15 and 22, 15 and 22, it will be 15, it will be 22. These are eliminated item. 22. Now it is also eliminated item. Array contains only two items. Heap contains only two items here, 15 and 20. 15 and 20. Again heapify it. 15 contains greater child 20, so one interchange will be done. 15 and it will be it will be 20 and it will be 15. Okay, change it, it will be 20, it will be 15. This is the status of array. Now interchange with root, 15 and 20. 15 and 20, and here 20 will be eliminated, and so tree contains only one item, so entire process will be stopped here and your array has been sorted. This is the concept of making it. Okay, look at this function. These are the numbers we have to sort using heap sort mechanism, and from main function heap sort will be called. This function will be called passing the array, and size will be 6 here, and no is name of the array, no. Okay, and two variables, local variables I and temp have been declared here, and build heap will be called. Build heap is another function which will create max heap of this array. We are passing no the array, and size is 6. Okay, and after making heap, this loop will work. It will interchange the root item with the last element, and it will decrease the heap size, because one time at a time one item will be eliminated. Each time one item will be eliminated, and again it will adjust all remaining items. So now at first we are observing this build heap, how it will work. Okay, so we are coming here. Okay, so we are not considering this array here. That array is sufficient. The name of the array at int size, that is 6. Heap size equals to size. Heap size equals to size means heap size is a global variable, and size is 6, so heap size will be 6. And only one loop is used here for I equals to size by 2 and I greater than equals to 1, I minus minus. And why we have written size by 2. Size is 6, 6 by 2, that is 3. And this index will be the parent node of last subtree. Okay, suppose this is the array and equivalent binary tree is 5, 6, 9, 3, 57. Just we have inserted all items one by one to make complete binary tree, and here last subtree is this one, and parent node of this subtree is 9. So observe the matter carefully. Size by 2, size by 2 is size is 6 and 6 by 2 3. I is 3, 3 will be the parent node of last subtree. This is 9. Okay, and so I is 3, 3 greater than equals to 1, condition is true. Heapify is one function mod we are calling from here no, and I is 3, and so it will be called I is 3, I is 3. I is 3. Okay, I am writing here same numbers. These are the local variables. L are large temp. L equals to I into 2. L will be I is 3. L will be 6. R will be 7. If L 6 less than equals to heap size, condition is true, and NOL NO6 greater than NOI NO3, NO6 greater than NO3, NO6 that is 22, 22 greater than 22 greater than 15, condition is true, and so large will be L 6. If R less than equals to heap size and NOR greater than NO large, R less than equals to heap size, R is 7, 7 less than equals to 6, condition is false, so large will remain 6 only, and here we are checking I not equal to large, condition will be true. Okay, here I am writing some notation. I am drawing the tree to better understand. This is the equivalent tree, and the value of I was 3, 3 is 15, and so left child will be index 6, right child will be index 7. If L less than equals to heap size, condition is true, and NOL NO6 greater than NOI NO3, 6 and 3, 6 is 22 and 3 is 15. 22 greater than 15, condition is true, and it has no any right child, so this condition is false. 22 greater than 15, condition is true, so large will be 22, that is index 6 here. This condition is false, and if I not equal to large, this condition is true, then these two items will be interchanged between I and large. Two items will be interchanged, again heapify will be called recursively, and it is true condition, so two items will be interchanged, I and large. It will be 22, 22, and it will be 15. change the array also 15 and 22. These two items will be interchanged. Okay, we have interchanged here 22 and 15. We are calling heapify again to adjust remaining items. Heapify no and large. Large is 6, so 6 will be passed here. 6 will be passed, but left of 6 will be 12. No any element, and 7 it will be 13. That means the index 6 15 has no any left child, no any right child, and so this condition will be false. L less than equals to heap size, no. L is 12. 12 less than equals to heap size. 12 less than equals to heap size is 6 and left is 12. 12 less than equals to heap size condition is false. So else large will be I. Large equals to I. Both values will be same, large and I. We are checking right hand side. Left hand side is false, then right hand side must be false because R is greater than L. If L is 12, then R must be 13. If L is 10, R must be 11. So large and I will be same and this condition will be false. Okay, because from this position the array is the subtree is already has become maxi and it has no any subtree. So we are going back from where we had called the heapify first time. We called from here heapify and I was 3 and now I will be decreased by 1. I will be 2. I will be 2. Again we are calling NO and I. NO and I is now 2. We are coming here, I is 2. All others items are same. Okay, I is 2 and so left child will be 4 and right child will be 5. Index 2 contains 30. So we are accessing this subtree. Already we have mapped this tree as maxheap and now we are creating maxheap, only this subtree. And 30 has 2 children, 25 and 35, 4th and 5, 4th and 5, 25 and 35. Okay, and here the condition will be L less than equals to heap size, condition is true. 4 less than equals to 6, condition is true. And NOL greater than NY. NOL is NO4, NO4, 25 greater than NY, NO2, 30. 25 greater than 30, condition is false. So large will be I. Large will be I, that is large will be 2. Large will be, large will be 2. If R less than equals to heap size, 5 less than equals to 6, condition is true. And NOR, NO5, 35 greater than NO large, NO2 is 30, condition is true. And so large will be R. Large will be R. Large will be 5. This index is greater. And I not equals to large, condition will be true. And so again I and large, element of I and large will be interchanged. I and large. And so okay, we have interchanged 35 and 30 equivalent array. Okay, we have interchanged 35 and 30, these two elements. And again heapify will be called NO by passing large. Large will be 5. large will be 5 and L will be 10, R will be 11. So same thing will occur as previous execution, and 10, 11, this condition will be false, so large will be I, and this condition also will be false. If this condition is false, then this condition must be false, and so I not equal to large condition will be false, and your execution control will go back from where you have called. Okay, you are coming here. I was 2, now I minus minus I will be 1. I is 1, 1 greater than equals to 1, condition is 2, again heap will be called NO and 1. NO 1, I is 1, L will be 2, R will be 3. If L less than equals to heap size, obviously true, 2 less than equals to 6, and NOL, NO2 greater than NOI, NOI is NO1, NO1 20, and NOL, NOI, NO1, NO1 20, and NOL, NOL2, NO2, NO2 is 35, 35 greater than 20, this one, condition is 2, large equals to L. Large equals to L. L is 2. Check right hand side. R less than equals to heap size, condition is true. 3 less than equals to 6, condition is true. And NOR, NO3 greater than NO2, NO3 greater than NO2, 22 greater than 35, no. And so this condition is true again. So one interchange will be done between I and large. Okay, we have interchanged these two elements. Similarly, array will be changed. 20 and 35. And 20, and again this heapify will be called. Now large is 2. I will be 2, recursively will be called this function. I is 2, and L will be 4, R will be 5. If L less than equals to heap size, condition is 2, and NOL, NO4 greater than NO2, NO4 greater than NO2, NO4 greater than NO2, condition is 2. So large will be L, large will be 4, large will be 4. R less than equals to heap size, R is 5, 5 less than equals to 6, condition true, and NOR, NO5 greater than NO4, NO5 condition is true, NO5 that is 30, and NO2 20, condition is 2, so large will be R, large will be 5, and I not equal to large, condition is 2, so one interchange will be done between I and large. I is 2 and large is 5, 2 and 5 will be interchanged. Okay, these two items has been interchanged, equivalent array will be interchanged. Again the heapify will be called NO and large. NO is array and large is now 5. 5 will be passed, but this condition will be false for second time, and your control will go back from where you have called. Here, and I minus minus, I is I was 1 and it will be 0, 0 greater than equals to 1, condition is false. This function will be false also, and control will go back from where you have called this function build heap, and we have called from here build heap, and so it will come again here. And now this loop will be started to sort all items. We have make max heap, and this loop will interchange the root item with the last, and again it will adjust all remaining items. Again it will shift down root to last position, and remaining items will be adjusted by this function. Okay. After making max heap, the sequence of element has been changed, and it will be okay. And here the loop will be started. I equals to size, I will be 6, I greater than equals to 2, condition is true. Temp, third variable has been used to interchange items no1 and no1 and noi. I6, 1 and 6 will be interchanged. 35, it will be 15, it will be 35. Heap size will be decreased by 1, heap size will be 5, so it will leave this item, and again it will call heapify no and 1 from one position. Again the heapify algorithm will work, and all items will be adjusted to make max heap. Okay, so after heapifying elements, control will come back, and I minus minus I will be 5, and again fifth position, the element of fifth position will come to first position, root will go to fifth position, and thus every time heapify will be called until this condition is false, and at last the array will be sorted. If you continue this heapifying process, then we will see how the algorithm is working, and I hope you will understand the matter. And now I am executing this program using C language. Heap sort include stdio.h conio.h as define size 10 void build heap int int void heapify int and void heap sort int. These three functions will be used in this program. int main declare, and you can also write your only main, it doesn't matter here. Int I n printf, enter number of elements, scanf %d address of n for I equals to 1. We leave the first index, that is 0. I less than equals to n I plus plus, sorry, printf enter value, scanf %d address of no I. Okay, display the elements first time before sorting. Elements are for I equals to 1, I less than equals to n, I plus plus, printf percentage d no I. And now call heap sort. From main function only heap sort will be called, and from the definition of heap sort, build heap will be called, and heapify will be called within a loop. Heap sort no and size and no here n minus 1, only n will be here, and again display the elements after sorting. Elements of array after sorting. Okay, and for I equals to 1, same thing will be replaced here. Control C. Get ch. Now define the functions. Void build heap or heap sort int no int size okay int I and temp will be used only. Build heap will be called and size for I equals to size I greater than equals to 2, I minus temp equals to 1 equals to I and I equals to temp heap size minus heapify and 1. This is the first definition. Void build heap int size int I heap size equals to size heap size equals to size, and for I equals to size by 2, I greater than equals to 1, I minus heapify and I. This is the definition of build heap, and one function mode. Void ep5 int no int I int I int L R large temp L equals to I into 2 R equals to I into 2 plus 1, and if L less than equals to if size and no L greater than no I, then large will be L, else large will be I. If R less than equals to heap size, if size and no R greater than equals to large equals to R, if I not equal to large, then interchange will be done here. Temp equals to NOI equals to NO large equals to temp ep5 NO and large. Okay, I am saving this program and executing this. Heap sort one error, array has not been declared here, n and no size, and modify it 100. That means array has 100 elements, from where you can use some items, some elements. We are accepting n, value of n will be given by the user, and n elements will be accepted. And heap size, a global variable, also will be declared here. Heap size. Function main accepted init declaration before printf. Statement missing. Okay, success. 5 elements, 52, 63, 4, 72. Okay, something is missing. Okay, here percentage F by mistake has been replaced. Okay. Okay. Success. 5 elements. 32, 25, 4, 96, 52. Something is missing. Again. Okay. And large. Suppose numbers are 10, 25, 96, 35, 64, 51, 24, 100, 50, 39, 17, 24, 25, 21. Okay. Thanks for visiting. If you have any doubt, you can contact me. My email is rps edushish at gmail.com, and my Skype ID is rps training. rps training. This is Skype ID. Thanks.